So in this video, I'll be explaining how to code this question of part C of the homework. So first thing is we need to put the variables in there that it gives us. And I already imported the functions that we're going to need beforehand. So shift enter. So let's say radius 1 is equal to 4.0 as it said. Radius 2 is equal to 2.0. Area of pipe 1, 2 is equal to 0.2. Area of pipe 2 is equal to the same thing there. Height initial one, so h I 1 is equal to it's at 5.0, then h12 is equal to 3.0. And you have the area, so area sphere 1 is equal to area of a sphere is 4 pi r squared. So p pi multiplied by r1 squared, and as2 is equal to jmp I times. You don't need the parentheses. I just do that for some just natural to me. So now that we have, I'm pretty sure we have all the variables that we can use so far, because we can't use these since we're not at that point yet. So we need the flow rates, and as I said in the last video, we have 0 is equal to qn sine times a12 2g. That's for q initial 1. This is going to be for q2. So as I go back, we're going to go, so q1 initial, q1n is equal to a12 multiplied by jp dot sine of h1 I minus h, and then we multiply it by j and p dot abs. Since we're going to need the absolute value, as I said in an earlier video, in case h2 is bigger than h1, so h1 minus hi2, and we're going to need the 2g, so I'm going to have to make a new function for that. So let's just say, let's call it grav. So it has gravity in it, equals square root p dot sqrt of 2 times 9.81. So this is a physical number, and I need to put on jp.sqrt for that as well. And that should give us our q1 initial, as at that page before, and q2, and it should equal all of this. Well, I won't need that actually, because it'll do if I remember, you get q2. Okay, so it's going to equal the same thing. So you're going to have q2 minus or plus Q1. And this is essentially Q12, I should say, minus area of 2 multiplied by JMP H. So you're going to get the same thing, except you're just subtracting this since there's going to be a flow rate out of the spherical tank too. So there's JMP, that's Q. To H. Times graph. I need to multiply these by graph. To graph. And that should let's print the values. So I'm going to invalid syntax somewhere. More than likely it's an extra parenthesis. Yeah. I believe that is the number. And print f of q and q. And this is supposed to be a positive number. So I did something wrong there. And what I did wrong is it's supposed to be all of that minus Q1N. And that should give us the correct number. So we're going to have to find how Q1 and Q2 changes with time. So let's make a new column. So we're going to have to make this a function. So define Q1 initial. That's it. Defined by time there. And define Q2 initial. Spelled initial wrong, and that's going to bother me. So we have that, and we're going to have to return some value from this. As this homework, this is when the point 80% after t equals 100, and then at t equals 200 to 2. But we are going to need something to break it in between so we can actually do that. And I'll move on to the next step before we do that next. And it's going to say invalid syntax. I do not have colons after this. So yeah. We're also going to have to define a function for change in height. We're going to have h, so height, time, and radii will also be changing. So I'll just put a small r there. So we're going to say the height, now it's not initial, so it's going to be height changing. It's going to be a value that changes with time. Same thing for h2. And now we're going to have to write these in with H1 and H2. So C but it's not going to be exactly the same as we had before. So we're going to say Q1, 2N, and then you're going to be QI. And you're not going to have the minus here. We just want this number. And this should be the same. We got to actually change here. It's going to be H1 and H2, since that is the function we were using. Oh, snap. I was doing it on the wrong thing there. So let me okay. Let's see how bad I messed up there. So yeah, minus QN. Q1N. Okay, good. Then I gotta change it here instead. So H1, H2, H1. Get rid of this. You don't want it. Q2, I, Q1, 2. And that will give us the flow rates that we need. And then we're going to have a return jp.array. What we need to get so we're going to have inside, I believe it's going to be Q. We're going to have to use Q1 initial as it deals with time. That's where we get that. So Q1 initial minus Q12, so that flow rate in parentheses here. And we're going to divide that by area of sphere 2, which we're going to define later in this. Since this is just the regular, we're going to have to do it when it's changing radius and time. And then we're going to get the other array, which is going to be Q2 initial minus Q2 I. In between there, we're going to have actually a plus. Should be Q12 initial. Right? And that is what we're going to need to return. So shift enter. And it's going to say invalid syntax somewhere. And I got to find out where it is here. I believe. Actually, no, it's not. I believe, actually, that you can only have one set on the entire function. It's still a good shade p.array. And there's that. I forgot the area of the sphere too anyway. I messed up that. Still coming on. Alright. So this is going to be the end of part 1 of the coding video, and I'll continue this and probably finish it in part 2 of the video.